For number one, we're gonna graph this log function and then apply this transformation. So when we are graphing log base 1/2 of x, we're gonna graph that part first. We wanna first rewrite this as an exponent. So it's 1/2 to the y power is equal to x. So that's how you would rewrite this log function as an exponential. So what I do now is I create a table and I'm gonna plug in -1, 0, and 1 for y to get x values, and these three values will be part of my graph on my A, B, C, and D here. So I'm gonna plug in -1 for y. So if I plug in -1 for y, it's 1/2 to the -1 power, and that's going to flip this fraction or the reciprocal, which is 2/1 or 2. So my first point is 2 -1. Then I'm gonna plug in 0. So 1/2 to the 0 power equals 1, because any number raised to the power of 0 is 1. Then I'm gonna plug in 1 for y. 1/2 to the first power equals 1/2. Okay, so these 3 points are going to be on my graph of f of x. So 2 -1, 1, 0, and 1/2, 1. So that's going to be my f of x function, but we're looking for the graph of my f of x function translated 2 to the left and down 3. So we want to remember the number inside the parentheses means your horizontal left and right translation, but you always change the sign. So this means left 2, and then the -3 is telling me down 3. So I'm going to translate these 3 points, left 2 and down 3. So I'll start here, left 2, down 3, left 2, down 3, left 2, down 3. And you can see that my answer is going to be A, just based on that. So also looking at A, we know that this is going to be our asymptote, because our asymptote's at 0, but then it's shifted 2 to the left. So you know you have an asymptote at -2, which works for A. It looks like on B, they have the asymptote at +2. So we know that can't be it. And then this one is at +2 again. And those points are definitely not what I've found. And then this has a horizontal asymptote. This is exponential, so we know our answer is not D. So this is why our answer is A. Number 2, we're looking for the vertex of this function. So to find the vertex, you use the formula x is equal to -b over 2a. So from this equation, we have a is -5 and b is 20. So I'm going to plug that in. Opposite b, or -b, is -20 over 2 times a, or 2 times -5. That's -20 divided by -10. That gives me +2. So my x value is going to be +2. So to find the y in the ordered pair, you're going to plug it back in. So I have -5 times 2 squared plus 20 times 2 minus 5. So, whoops, I'm plugging in 2 for my x here and here. So order of operations, I'm going to square the 2 first, and I get -5 times 4. And then I'm going to copy down the rest. Next, I'm going to multiply -20 plus 40 minus 5. And that's 20 minus 5. That's going to give us 15. So my vertex is 2, 15. Number 3, they're asking us to find the value of x given this log function. So let me just rewrite it over here really quick. So when I'm solving for x, I want to get rid of log base 8. So to get rid of the log base 8, you're going to use an exponent base 8 and raise both of those sides. equal sign. So when you have your 8 raised to the log base 8 power, they're going to cancel out and leave you with x is equal to, and then we have 8 raised to the negative third power. So remember, it doesn't mean 8 times negative 3. 8 is your exponent raised to the negative third power. So we remember the exponent, when it's negative, is going to move it to the bottom of the fraction. So it's now 1 over 8 cubed. And 1 over 8 times 8 times 8 is 512. Number 4, we are given a certain radioactive element decays over time according to this equation. And they're telling us that A is the number of grams present initially, and T is going to be our time in years. So they're telling us that 6,000 grams are present initially. So 6,000 is going to be my A value. And then 9 years, they're asking, is going to then be my T. So 6,000 is my A value and 9 is going to be my T that I'm just going to plug in here and here to my equation. So this equation will be 6,000 for A times 1/2 raised to the 9 divided by 3 power. Again, plugged in 9 for T, plugged in 6,000 for A. So we can put this into a calculator, but we aren't going to be using a calculator on our open or on our multiple choice. So we have to know how to simplify this without. You would first divide 9 and 3 and get 3. So here we take care of our exponent first. So we're going to do 1/2 raised to the third power. So 1/2 raised to the third power is going to be 1/2 times itself times itself. So multiplying across, you get 1 over 8. So now my equation is y equals 6,000 times 1 over 8. Again, because 1/2 cubed is 1 over 8. So I'm multiplying a whole number by a fraction. I want to make this a fraction by putting a 1 underneath. And then I'm going to multiply across. 6,000 times 1 is 6,000. 1 times 8 is 8. So I need to simplify 6,000 over 8. So what we can do, there's several ways you can do it. You can simplify the fraction first, but I'm just going to go ahead and do my division. 6,000 divided by 8. 8 goes into 60 7 times. 7 times 8 is 56. Then I'm going to subtract. 40 divided by 8 is 5. And bring down the 0. 6,000 divided by 8 is 750. So that's why my answer for number 4 is D. Number 5, we're going to evaluate this without using a calculator. So whenever we are evaluating a log, you look at the base. In this case, it's a base 4, and we ask ourselves 4 to what power is going to equal 16. So our answer is 2. Number 6, which of these is the first incorrect step for log base 4 of 4 times 64? So when we are multiplying, when we have the log of a number, you separate them using addition. So log base 4 of 4 plus log base 4 of 64 is completely correct. So step 1 is good. Then step 2, it looks like they're starting to simplify. Log base 4 of 4 is 1 because 4 to the first power equals 4. So the 1 is good. But when they simplified right here, log base 4 of 64 is 3 because 4 to the third power equals 64. So this should not be 16, it should be a 3. So step 2 is where they made their first incorrect step. Number 7, I'm going to simplify. First, I'm going to raise all of these coefficients and variables to the power of 2. So it becomes 2 squared, a to the 4th power, b to the 4th power, c to the negative 10 power. when I use that exponent of 2 for everything in parentheses. Then I'm just going to copy down the bottom and then go ahead and simplify. So 2 squared is 4. That's my only coefficient, and that's the only number, so it has nothing to divide or multiply with. We're going to leave that. I'm just going to go ahead and cross it out just so it doesn't get in our way. Then I'm going to look at my a terms, a to the 4th power and a to the negative 2. A to the negative 2 power needs to move to the top to make the 2 a positive exponent. So now that a to the 4th power, a squared are on the same level, or they're multiplying, you're going to add the exponent. So you get a to the 6th power. So I'm going to cross those out, get them out of our way. Then I have b to the 4th power and b to the 7th power. Neither of those exponents are negative, so we're not going to move them, but our rule when we're dividing is to subtract. 4 minus 7 is negative 3. So my negative 3 is going to move to the bottom, and we have b to the positive 3rd power on our denominator. And then c to the negative 10 power is going to move to the denominator and become positive 10. So c to the 8th power times c to the 10th, you add your exponents, and your answer is D. Number 8, we're gonna figure out which graph best represents the solution to this system of inequalities. So the first thing we're gonna do is we're gonna rewrite this in slope-intercept form so that we know where this graph is supposed to be. So I'm gonna start by subtracting 3 to both sides. And this one's going to be rewritten as negative 3 over 5x minus 3 is greater than y. So that's what I would do if I were to get y by itself. But when we are graphing our inequalities, we want to have it where y is not on the right side, but on the left side. So I'm going to rewrite this by switching everything. So y is going to come to this side, and then you also switch your inequality. And then we have negative 3/5 x minus 3. So we're looking for y is less than negative 3/5 x minus 3 as our first inequality. And then our second inequality is going to be y is greater than negative 3. So I'm going to start by looking at this one. Y is greater than negative 3 is going to be a horizontal line at negative 3. But if you look at part A, it's shading underneath. Greater than should be shading above. So my answer is not A. For B, y equals negative 3. Again, they're shading below when they should be shading above. So my answer is not B. For C, we have y equals 3. And yes, it should be shading above. So far, this looks good for y is greater than negative 3. Now I'm going to look for this graph that we rewrote. So we start at negative 3, and then we have a slope down 3 over 5. So because this is less than, from this line, we do want to shade below. And the graphs intersect right here, so my answer's C. The answer is not D because in D, they shaded above this, and this less than means shade below. So my answer is not D. But please do keep in mind there's a mistake right here. This should not be a solid line. It should be a dashed line because this is a less than. There's no underline, so it should be a dashed line. So we're looking for which equation works for all real numbers. So if we look at A, log base 5 of x minus log base 5 of y, we would condense that using division because of the minus sign. So the way that they rewrote that, multiplying x and y, is completely incorrect. So we know our answer is not A. For part B, we're looking to see if when they rewrote this, let's look at how to rewrite this. So if I have that, what I could do is rewrite it like this. So I took out the negative 1 exponent and wrote it on the outside of the parentheses. So if you were to distribute the negative 1 back in, it would look like this. So I took out that negative 1 exponent, which would mean if I were to rewrite this, it would be x plus y to the positive 1 power, because the negative 1 power tells me to move x plus y to the top of my fraction. So now I end up with x plus y for this whole thing that I circled in orange, which is still multiplying by x plus y here. If I were to multiply these together, it's definitely not giving me x times y. So that is going to be completely incorrect for part B. For part C, we're looking at this. Our rule is to multiply your exponents. So if I were to multiply, I'll show the work over here. I'd put a 1 underneath the 20 and then multiply 20 over 1 times 1/4. And that would give me 20 over 4, which is x to the 5th power. And that's what they have for part C. So let's look at that. So I'm thinking C might be our answer. But if you look at part D, if you have x to the 7th power, and you're doing the 7th root, the 7 and 7 cancel out to give you x. So C and D both look good, but we want to know when it's always true for all real numbers. So let's just plug in some numbers to see what happens with x to the 20th power. So if I were to plug in a -1, so if I have -1 to the 20th power raised to the 1/4 power, so if I'm plugging in -1 for x, let's see what answer it would give us. So -1 to the 20th power is going to be +1, because anytime you do the negative number raised to an even number exponent, it's positive. So we get +1 for -1 to the 20th power. And then +1 raised to the 1/4 power is going to be +1. So if I were to plug in -1 here and plug in -1 here, it wouldn't give me +1. So plugging in -1 for x to the 20th power to the 1/4 power gave me 1. But if I plug it in for x to the 5th, so now I'll plug in -1 to the 5th power. -1 to the 5th power is -1. 1 and -1 do not equal each other. So C also cannot be an answer, because when you plug in a negative number for x, the 20th power, the even power, is going to get rid of the negative. But you have an odd power over here that's going to keep the negative. So that's why these are not going to work for all real numbers. If you look at part D, anytime you plug in a negative number for x, it's going to, because of the odd exponent, it's going to keep the number negative. And then you're able to take the odd root of a negative number, it's going to keep it negative. So taking the odd root and odd power will keep it a negative number, which is why D would work. So if you guys want to see, let's use this paper. If I plug in -1 here to show you what I mean by that, let's plug it into both sides. -1 to the 7th power is going to stay -1, because the odd exponent, it stays negative. The 7th root of -1 is -1, because anytime you take the odd root of a negative, it'll stay negative. So this does work, and it will work for all your odd numbers and all your positive and negative numbers. So that's why your answer is D. Number 10, I'm looking for which expression represents f of g of x. So f of g of x means we are going to take our g of x function and plug it into our f function. So here's my g of x function that I'm going to plug in for my x in my f of x function. So I like to start by writing the f of x function. So it's x squared plus 8, but we're going to replace x with the g function. So it's going to be x minus 4 squared plus 8. We want to remember x minus 4 squared doesn't mean x squared minus 16. It means we're going to rewrite this twice. And then we're going to multiply. X times x is x squared. X times -4 is -4x. -4 times x is -4x. -4 times -4 is 16. And don't forget about that plus 8. When I combine like terms, x squared minus 8x plus 24 is going to be my answer when I multiply and combine like terms. Number 11, I have the difference of two perfect cubes. So we are going to be using the difference of two perfect cubes formula, which is a minus b, a squared plus ab plus b squared. And remember, you want to memorize the formula. Helpful way for memorizing is to remember SOP. This means same sign, opposite sign, plus sign. That'll help you with your signs. So since my original equation has a negative, we're going to keep that same sign negative, then change that sign to the opposite, and then always ending in a plus sign. So SUP will help you with that. So what we do now is we find the A and find the B value to plug into the equation. So to find the A value, you're going to take the cube root of the first term. So the cube root of 64 is 4, and the cube root of A cubed is A. So my A term is 4A. My B term is going to be the cube root of the second term. The cube root of 27 is 3, and the cube root of C cubed is C. So we're going to plug in 4A and 3C to this equation. So when I do that, I get A minus B, then A squared, which is going to be 16A squared, plus A times B, which will be 12AC, plus B squared, which will give us 9C squared. So our answer can't be those. It's going to be B. We're looking for the solution to this equation. 2 to the x power equals 50. So if I want to get rid of this exponent base 2, I need to do the inverse operation. That's going to be raising both sides using the log base 2. So log base 2 of 2 will cancel out to leave us with x equals log base 2 of 50. So when I have log base 2 of 50, we are going to break that down using our change of base, which is log of 50 divided by log of 2. So it's log of 50 divided by log of your base, which we know means log base 10 of 50 and log base 10 of 2. So our answer is D. Number 13 asks, what are the x-intercepts for this? So we're going to go ahead and factor and set the factors equal to 0 to find those x-intercepts or solutions. So I'm going to factor 4x times x, multiply numbers to get to 5, that'll add up to positive x, will be 5 times 1. X times 5 is 5x, 4x times 1 is 4x. To get to positive 1, this would have to be a positive 5, negative 4. So my factors are 4x plus 5 and x minus 1. So I take each of the factors and set them equal to 0. So x is equal to negative 5/4 and x is equal to positive 1. Our answer is A. Number 14, we're looking for the product of factors that's equivalent to this. So I'm going to start by simplifying this. That's going to be x minus 4 times x minus 4. That's what x minus 4 squared gives us. And when I distribute, I get this for my two binomials. Then I'm going to combine like terms. And I'm looking for A, B, C, or D when I do these operations to give me this. So if I look at A, let me get some scratch paper. If I were to multiply A, it would look like this. Okay, right? X minus 4 minus y squared. So if I were to FOIL all of this out, the last thing I would do is multiply negative y times negative y, and it would give me positive y squared. This has to be a negative y squared. That's a way I can see easily that A won't be my answer. For B, if I were to multiply, oops, sorry, let me try again. X minus 4 plus y squared means multiplying it to itself. Again, if I were to multiply the y and the y, which you would do last, right? If you were foiling and distributing, you'd get positive y squared, right? Positive y times positive y is positive y squared. And again, you want that y squared term to be negative, so it can't be B. So looking at C, I have, if I were to multiply this out, multiply every x by everything first, you get x squared minus 4x minus xy. Then I'm going to distribute negative 4 to all of these three terms and get negative 4x plus 16 plus 4y. Then I'm going to multiply y to all three of these terms. I'm going to write it down here. Plus xy minus 4y minus y squared. These are all the terms I would have if I were to multiply all of those. So when I combine like terms, x squared stays. Negative 4x and negative 4x combined to give me negative 8x. I'm going to go ahead and cross those out. I combined them. Then I have negative xy and positive xy, which will cancel each other out. I have positive 4y and negative 4y cancel each other out. And I have positive 16 left and negative y squared. And that is what I want. So I know my answer is C. Number 15, we're looking for the equation that's equivalent to this. So if I had log base 8 of 1 over 6 equals x, and if I were going to rewrite this, it looks like they're rewriting using exponents. We know that there's different ways to do this. I'm going to actually raise both sides using my 8, my exponent. So that big 8 cancels out to give me 1 over 6 is equal to 8 to the x power. So that's one way to do it. I think that's the easiest way. If you were to rewrite that, you would get B as your answer. Number 16, we have log of 3 over 40. So remember, if I were to rewrite this, or if I were to expand, because of the fraction, it's log base 10, or just log, of 3 minus log, or log base 10 of 40. It's a minus sign because of the division. The rule is when it's dividing, you expand using subtraction. So that's how my answer is A. It's not addition. Addition would be if 3 and 40 were multiplied. We never multiplied like this, ever. And then we're not dividing. They're trying to trick you. You would do this if it was saying find log base 3 of 40. And that's not what they're giving us. So it's not D. Answer is A. Number 17, bacteria in a culture are growing exponentially as shown in this table. So we're looking for which one of these equations matches the information in the table. So this information is giving me x values and y values, or t values and y values. So they're not using x, they're using t. So t is going to stand for the number of days, for time, and y is going to be the bacteria grown. So what I'm going to do is I'm going to plug in t, and I want to see which one of these equations, when I plug in the t, gives me the correct y. So I'm going to start with part D. If I were to plug in my first t, which is 0, it would look like this: 100 times t to the 0 times 2 to the 0 power. So if I were to simplify 2 to the 0 power, it gives me 1. 100 times 1 equals 100. And that's not what I should get for y. I'm looking to get y equals 50. So my answer is not D. So let's try plugging in 0 for part C. If I were to plug in 0 for t, I would get 50 plus 2 to the 0 power. 2 to the 0 power is 1. 50 plus 1 is 51. We're again looking to get y equals 50, so my answer is not C. If I were to plug in 0 for t, for part B, you get 2 to the 0 power is 1. Again, not 50, so our answer is not B. So it's got to be A. If I were to plug in t 0, I get 50 times 1, because 2 to the 0 power is 1. 50 times 1 is 50. So my answer is going to have to be A. And then I'm going to go ahead and plug in, again, let's plug in 1 for t, just to make sure. 50 times 2 to the 1 power is 50 times 2, which is 100. And that's exactly the y value we wanted to get when we plugged in 1. And then if we plug in 2, we'll just go ahead and do that. You get 50 times 4, and 50 times 4 is 200. That's the y value we want. So our answer is A. Okay, Mike wants to approximate the value of log base 3 of 6. The only information he's given is that log base 3 of 30 is 3.0959, and log base 3 of 5 is this. So we're going to use an expression to approximate the value of log base 3 of 6. So this is us having to approximate log base 3 of 6 if we're not able to use a calculator. So what we're going to do is we're going to want to expand log base 3 of 6 using addition and subtraction. So if I want to rewrite log base 3 of 6, I'm going to want to rewrite 6 using the numbers they gave me, 30 and 5. So we know that 6 can be rewritten using 30 and 5 because 30 divided by 5 is 6. So we're going to rewrite 6 as 30 divided by 5. So we're going to expand this. So it's log base 3 of 30 minus log base 3 of 5. That's how we would break this down. So I rewrote 6 as 30 over 5, and we separate the division using subtraction. So my answer has to be C. Again, addition would be if I were multiplying 30 and 5, and then we never multiplied the logs ever. This one is tricking you. This is if they were breaking down. Actually, I don't even know. That doesn't make any sense. Don't let that confuse you. We're going to use subtraction to expand this. So answer C. Okay, number 19, we're going to be subtracting f of x minus g of x. So I'm going to copy down my f of x function minus my g of x function. And it's very important when you plug in these functions to use parentheses, because this minus sign is going to tell me to distribute the negative to all of my terms in my g of x. So it's 12x plus 17 plus 17x squared minus 5x minus 25. So combining like terms, I have 17x squared. 12x and negative 5x is positive 7x. 17 minus 25 is negative 8. So my answer is D. Okay. We're almost done with the multiple choice. Number 20, which expression has a value of 2? So we're going to go and simplify each one of these. So log base 4 of 1 means 4 to what power gives me 1? It's going to be 0. My answer is not A. ln and e are inverses of each other. They cancel out and leave me with my exponent 2. So my first answer that gives me 2 is B. Log base 4 of 16 means 4 to what power gives me 16, and that's 2, so my second answer is C. ln of 1, remember ln means log base e, so e to what power gives me 1? That's going to be 0. My only answers are B and C. The last multiple choice question, we're going to select the value of B for which this equation is giving us this graph. So this is our exponential growth. So when I have an exponential growth graph, my B value or my base has to be greater than 1. So we're looking for the values of B that are greater than 1. 2.3 is greater than 1. 8 is greater than 1. 3/14 is less than 1, so we can't choose that. And 0.23 is less than 1 as well. So that's why my answers are only A and B.